All right, today we're going to be talking about other types of equations, specifically some radical equations and how to deal with those. Okay, so it says solving radical equations containing nth roots. It says if necessary, arrange terms so that one radical is isolated on one side of the equation. And then whatever your index is, you're going to raise both sides. Once you've isolated it, you can kill it. So let's say that I isolated a cube root of something. To kill a cube root, you would cube it. The only rule is you would have to do it to both sides. That would kill the cube, which is going to get your x out. Okay, and then you solve the resulting equation. And then if it still contains radicals, you repeat. And then you have to make sure you check all of your solutions. If you plug your solutions back in and you don't get a true statement, those solutions are called extraneous solutions or extraneous roots because they don't ring true when you plug them back in. Alright, so do you see my radical here? I need to isolate that so that I can kill it, which means I've got to get rid of this plus 2. So to get rid of the positive 2, I'm going to subtract 2. That's going to give me the square root of 2x minus 1 equals x minus 2, because you can't add an x and a 2. Now that I've isolated it, excuse me, I can kill it. Because this is a square root, I can raise it to the second degree, and that will eliminate it. But I got to do it to both sides. Now over here, the square kills the square root, and I'm left with 2x minus 1. Over here, to square that without killing puppies, you have to make 2 copies in FOIL. So, x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Combined like terms, I get x squared minus 4x plus 4. And that still equals, I haven't done anything to the other side, 2x minus 1. Okay, so now I've gotten rid of the radical. I've eliminated that square root. So now I can focus on getting x alone. If it's a second degree function, you've got to get 0 on one side and then either factor or do quadratic formula. I don't want a negative squared term, so I'm going to move these guys that way. So I'm going to minus 2x. And I'm going to do 2 things at once if I don't mind. And then I'm going to add 1, which gives me 0 equals x squared minus 6x plus 5. Now I've got a quadratic equation, so I can either do factoring or quadratic formula. I'm trying factoring. A is 1. It should be an easy one if it's not prime. Factors of 5 that make 6 would be 5 and 1. Since C is positive, then they both get the middle sign, which is minus. So then when I set them to 0, x minus 5 equals 0, x minus 1 equals 0, add 5, I get x equals 5, add 1, I get x equals 1. So my solutions are 5 and 1 unless they're bad answers. And what I mean by bad answers is if you plug it back into a radical equation and you get a negative underneath an even root, you have to throw it out because it's not going to be real. If I substitute 5 back in, 2 times 5 minus 1 plus 2 equals 5. If it's true, then I can keep the solution. If it's false, then I can't. That's 10 minus 1 is 9. The square root of 9 is 3. Plus 2 is 5, and 5 equals 5. So this one's good. I can keep it. If I plug in 1, the square root of 2 times 1 minus 1 plus 2 equals 1. I changed all my x's to 1s, and I'm seeing if it's true. This would be 2 minus 1 is 1. Square root of 1 is 1. 1 plus 2 is 3. 3 does not equal 1, so I have to throw this one out. It's extraneous. It's bad. My only solution is 5. And I can actually show you on the graphing calculator. I had to get everything on one side, so I had to move the x over, but then I typed it in, calculated to 0, and you can see that it only crosses at 5. It does not cross at 1. It's right mathematically. It just doesn't fit in the context of this problem, so we throw it out. Alright, so let's try this one. Again, I've got to isolate this radical, so I'm going to minus x. That's going to give me negative square root of 2x plus 5 equals negative x plus 5. Still not isolated. I need to get rid of that negative, so I'm going to divide everything by a negative, which gives me the square root of 2x plus 5 equals x minus 5. Now I've isolated it, I can kill it, so I'm going to raise it to the second, but I got to do it to both sides. The square kills the square root, which leaves me 2x plus 5. On this side I have to make 2 copies, or I'll kill puppies. And if I simplify, x times x is x squared, x times negative 5 is negative 5x. Negative 5 times x is negative 5x. Negative 5 times negative 5 is positive 25. Clean it up. X squared minus 10x plus 25 equals 2x plus 5. It's quadratic, so I need to get 0 on one side. So I'm going to minus 2x, and I'm going to minus 5 and minus 5. If you don't mind, I'm going to do 2 things at once. Combine like terms, and I'm going to have x squared minus 12x plus 20. I'm going to try and factor that. Should be easy. A is 1. Factors of 20 that make 12. 1 and 20, no. 2 and 10, yes. So 2 and 10 make 12. Because C is positive, then they both get the middle, which is minus. So then if I set them to 0, x minus 2 equals 0, x minus 10 equals 0, add 2, x equals 2, add 10, x equals 10. Those are my 2 answers, as long as they don't make drama. They don't make negatives under the radicals and stuff. So I'm going to have to test them. If I change all my x's to 2, I'd have 2 minus the square root of 2 times 2 plus 5 equals 5. That's going to be 2 minus 2 times 2 is 4 plus 5 is 9. That's going to be 2 minus 3. That's going to be negative 1, which isn't true. So I have to throw 2 out. If I plug in 10, 10 minus the square root of 2 times 10 plus 5 equals 5. That's going to be 10 minus the square root of 25 equals 5. That's 10 minus 5, which is 5 equals 5, so I can keep it. My only solution is 10. And if you look on the graph, you can see that it crosses at 10. Alright, you try this one. Well, gee, I guess you can see the answer right there. Try the math though, please. I meant to animate that. Alright, if you didn't get that, let's look at y. I've got to isolate the radical. So I'm going to minus x. Gives me negative square root of 3x minus 2 equals negative x plus 4. Divide by a negative. I get the square root of 3x minus 2 equals x minus 4. I can now kill it by squaring both sides. That's going to give me the square root of, kills the square root. That's going to give me 3x minus 2 equals 2 copies of x minus 4. X times x is x squared. Negative 4x, positive 16. Clean it up. X squared minus 8x plus 16. Quadratic, I need to get 0 on one side, so minus 3x, add 2, there's my 0. Combine like terms, x squared minus 11x plus 18. I'm going to try and factor. Factors of 18. 1 and 18 will not make 11. 2 and 9 will. Since C is positive, they both get the middle, so they're both minus. So x equals 2 and x equals 9. If I test them, if I plug 2 back in, 2 minus the square root of 3 times 2 minus 2 equals 4. That is 6 minus 2 is 4. Square root of 4 is 2. 2 minus 2 is 0. 0 does not equal 4, so I have to throw it out. Plug in 9, check 9. 9 minus the square root of 3 times 9 minus 2 equals 4. That's 9 minus, that's 27, minus 2 is 25. Square root of 25 is 5. 9 minus 4 is 4. 4 equals 4. I can keep the 9. Okay? Alright, we're going to get a little more complicated because now we have two radicals. Well, you're going to have to isolate one and kill it, and then isolate the second one and kill it. So I need to get one of these alone. I'm going to keep this one, and I'm going to move this one. So I'm going to add it to both sides, and it doesn't matter which one you pick. So that's going to give me the square root of 3x plus 1 equals the square root of x plus 4 plus 1 on the outside. So now I can square to eliminate, but I got to do it to both sides. This is going to give me 3x plus 1. This I'm going to have to make 2 copies of. Now, when you do this, the square root of x plus 4 times the square root of x plus 4 is x plus 4. Because it'd be the square root of x plus 4 squared, but then the square would kill the square root, and you just get the square root. I mean the x plus 4. This square root of x plus 4 times 1 is the positive square root of x plus 4. This is a positive 1 times the square root of x plus 4, and this is positive 1. Combine like terms, which those guys are like terms, and so are these guys. I have 3x plus 1 equals x plus 5 plus 2 square roots of x plus 4, because you don't add the insides, you just add the outsides when they match. So now I have to isolate this radical so that I can eliminate it. So I'm going to minus x, I'm going to minus 5, and I can't divide by 2 until you get done the adding and subtracting. So combine like terms, I get 2x minus 4 equals 2 square roots of x plus 4. Okay? Now, you could actually eliminate now once you have just everything but something touching. Or because these two are divisible by 2, I'll go ahead and eliminate the 2. But if 2 didn't divide evenly into this, I would go ahead and square both sides right now. You just have to square the 2 also. But it works. So I get x minus 2 equals the square root of x plus 4. Okay, I'm going to write that up here. So now I have x minus 2 equals the square root of x plus 4. My radical is now once again isolated, so I can kill it. But I got to square both sides. So 2 copies equals x plus 4, because the square kills the square root. This is going to give me x squared minus 2x plus 4 equals x plus 4. It's clean it up, so I have x squared minus 4x plus 4 equals x plus 4. I need to get 0 on one side, so minus x minus 4 minus 4. I get x squared minus 5x equals 0. To solve this one, I'm going to factor. I can factor out an x, which would leave x minus 5. Set them to 0. This one's already done. Add 5, x equals 5. Those are my solutions unless they don't work. So if I test them, I have the square root of 3 times 0 plus 1 minus the square root of 0 plus 4 equals 1. This is 0 plus 1 is 1 minus 0 plus 4 is 4. That's 1 minus 2. That's negative 1, which does not equal positive 1, so I have to throw 0 out. Plug in 5, the square root of 3 times 5 plus 1 minus the square root of 5 plus 4 equals 1. That's 15 plus 1 is 16. 9. That's 4. That's 3. That's 1 equals 1. I can keep the 5. Okay? And you can see that right there is when we place the crosses. Alright. So now we've got 3 radicals for crying out loud, but I'm going to focus on this one for right now, and it's isolated, so I'm going to go ahead and square both sides. This will kill it, which leaves me 1 plus 4 square roots of x. It doesn't kill the inside one. On this side, I have to make 2 copies. So 1 times 1 is 1. 1 square root of x plus 1 square root of x plus x. Clean it up. Combine like terms. I have 1 plus 4 square roots of x equals 1 plus 2 square roots of x plus x. Okay, so now I still have a radical. There's 2 of them actually. I need to get them together and isolate it because the radicals match, so I can combine them. So I'm going to move my 2 square roots of x over, which gives me 1 plus 2 square roots of x equals 1 plus x. Now I need to try and isolate this radical. So I'm going to minus 1. Works out good for me. That's 2 square roots of x equals x. Okay, divide by 2. And I get the square root of x equals x over 2. Now I can kill it. So I'm going to square both sides, and I get x equals x squared over 4. So now, I'll copy that over. I need to get 0 on one side, but I also want to kill that fraction. So I'm going to multiply both sides by 4, which gives me 4x equals x squared. I want 0 on one side, and I don't want my squared term negative, so I'm going to minus 4x. And I get 0 equals x squared minus 4x. I'm going to factor that. I can factor out an x, which would leave x minus 4. So x equals 0, x minus 4 equals 0. That one's done. Add 4, x equals 4, which are my answers unless I can't keep them. So if I try 0, the square root of 1 plus 4 square roots of 0 equals 1 plus the square root of 0. Well, the square root of 0 is 0, times 4 is 0, so that's the square root of 1, which is 1. That's 0. 1 plus 0 is 1. 1 equals 1, so I can keep 0. Plug in 4, square root of 1 plus 4 square roots of 4 equals 1 plus the square root of 4. Square root of 4 is 2, times 4 is 8, plus 1 is 9, which is 3. Square root of 4 is 2, 1 plus 2 is 3, 3 equals 3. Oh, I can actually keep both of my answers because they both work. Okay, and if you see on my picture, this is 2 point, see how it crosses at 4, and this is 2.37e negative 25. That means the decimal is 25 units this way, so it's 0.000000. For all intents and purposes, that's 0. So is that. Alright, so try this one, hit pause, come back when you're ready, and hopefully you got negative 2. Alright, we've got 2 radicals, so I need to isolate one. I'm going to isolate this one, so I'm going to minus the square root of x plus 6, and that's going to give me the square root of 2 minus x equals 4 minus the square root of x plus 6. I've isolated one, so now I can square it to kill it, but I got to do it to both sides. That's going to give me 2 minus x. I've got to make 2 copies of this so I don't kill puppies. 4 times 4 is 16. This is going to be negative 4 square roots of x plus 6. This is going to be negative 4 square roots of x plus 6. And this is going to be a positive x plus 6. Okay, so if I clean this thing up, combine like terms, I get 2 minus x equals 16 plus 6 is 22 plus x minus 8 square roots of x plus 6. So now I need to get this radical alone. So I'm going to minus 22 minus x. I get negative 20 minus 2x equals negative 8 square roots of x plus 6. Now, normally I would isolate by dividing everything by negative 8, but 8 isn't going to go into 20 evenly or 2. So I don't want to. And I actually, as long as all that's left is a multiplier, you can go ahead and square now. Okay, so if I make 2 copies of this, and on this side it's going to be you square the negative, which is positive, you square the 8, which is 64, you square the square root, which is x plus 6. Notice how I put it in parentheses because I'm going to have to distribute that 64. So over here I'm going to have 400 plus 40x plus 40x plus 4x squared equals 64x plus 384. Okay, so now if I clean this mess up, I have 4x squared plus 80x plus 400 equals 64x plus 384. Now I need to get 0 on one side because I'm quadratic, so minus 64x gets rid of that, minus 384 gets rid of that and gives me my 0. I have 80 minus 64, so I have 4x squared plus 16x. 400 minus 384 is 16 equals 0. I can factor out a 4, which would leave x squared plus 4x plus 4. Keep the 4, factor the trinome, x and x. Factors of 4 that make 4 are 2 and 2. Since c is positive, they both get the middle plus, which gives me, you can try 4 equals 0, but there's no x in it, so it's not a 0 factor. X plus 2 equals 0, x plus 2 equals 0, minus 2, x equals negative 2, minus 2, x equals negative 2. You get negative 2 twice. And if you plug it back in, it works. Alright. Try this one. Hit pause, come back when you're ready. And hopefully you got 0 and 100. Alright, this one is already isolated, so I'm going to square both sides. That makes 1 plus 12 square roots of x. I have to make 2 copies on this side, which is going to be 1 plus the square root of x plus the square root of x plus x. So clean it up, and I have 1 plus 12 square roots of x equals 1 plus 2 square roots of x plus x. I need to get my square roots of x's together, so I'm going to minus 2 square roots of x. I get 1 plus 10 square roots of x equals 1 plus x. Minus 1 minus 1. I get 10 square roots of x equals x. I can go ahead and square, I could divide by 10, but again, as long as you have a multiplier, you can go ahead and eliminate. So that's going to be 100x equals x squared. I need to get 0 on one side, so minus 100x minus 100x. I get 0 equals x squared minus 100x. I can factor out an x, which leaves x minus 100. So x equals 0, x minus 100 equals 0, add 100, add 100, x equals 100, and then you'd have to test them, but they both work. Alright. Alright, solving radical equations in the form of x to the m over n equals k. All you do is, instead of taking the root because it's a fraction, you raise it to the reciprocal. Because when you power, you multiply, and this would be mn divided by mn, which would just be x to the first, and that's how you eliminate the radical. But whatever you do to one side, you have to do to the other. Now, if the top degree is even, you have to do plus or minus when you raise both sides. If the top is odd, you don't. It's just the straight regular. Don't forget that. Even numerator means plus or minus in your answer. Alright, so again, I've got to isolate and kill. I need to isolate this x to the 3/4. So I'm going to add 6. That gives me 3x to the 3/4 equals 6. Divide by 3. I get x to the 3/4 equals 2. Now that I've isolated it, I can eliminate it by raising it to the reciprocal. That will kill it, which gives me x alone. And my answer is 2 to the 4/3. Now, unfortunately, you have to figure out what that is. So you're going to have to go back to radical. The 2 goes underneath, the 4 goes on top, and the 3 goes in the index. Okay? So now, guys, even if this is a number, what's easiest to do is you just divide the 4 by 3. 3 goes into 4 one whole time, with 1 remainder, which means 1 copy of 2 is out and 1 copy of 2 is in. So this comes to 2 cube roots of 2. That would be what my x equals. Okay? You could type it in a calculator and do 2 caret parentheses 4 divided by 3, and it will tell you 2.5198421. But again, they're not going to want decimal answers, so you've got to reduce your radical. Alright, and if you see, it actually does cross at 2 cube roots of 2, which is 2.5198421. Okay? Alright, so let's try this one. Again, I've got to isolate this guy, so I'm going to add 3/4, add 3/4. I get x to the 2/3 equals, if I have negative 1/2 and plus 3/4, my common denominator would be 4. So times 2 makes that negative 2/4 plus 3/4, which makes 1/4. Okay, so I've isolated it. Now I'm going to raise it to the reciprocal, 3/2. Okay, this is going to cancel, which gives me x alone. This is going to be 1 to the 3/2 over 4 to the 3/2. 1 to anything is 1. On bottom, this is going to be the square root of 4 cubed. Well, again, 2 goes into 3 one whole time. Take away 2, which leaves 1 left over. So 1 copy of 4 is out, and 1 copy of 4 is in. So this is 1 over 4 square roots of 4. Oh, because it's perfect. Anyway, sorry, the square root of 4 is actually 2, so that makes x equals 1/8. And this one you actually could, if you typed parentheses 1 divided by 4 parentheses caret parentheses 3 divided by 2 parentheses and hit enter and then hit math enter, it would have given you 1/8. Alright, and you can see there it's crossed. The top, where was I? The top was even, so this has to be plus or minus. And you can see on the graph it crosses at positive 1/8 and at negative 1/8. Okay? Alright, so you try this one. Come back when you're ready. And hopefully you got negative 61/3. Alright, I got to isolate, so minus 3, 6x minus 3 to the 1/3 equals negative 5. I've isolated it, so now I can raise it to the reciprocal, which would be 3/1, or just 3. That will cancel it, which gives me 6x minus 3. Calculated this, that's going to be negative 125. It's linear, so all I have to do is get x alone. So add 3, I get 6x equals negative 122. Divide by 6, x equals negative 122 over 6. Reduce it is negative 61/3, which as a decimal is negative 20.3 repeating. Alright, try this one. Come back when you're ready. And you should get negative 12 and 6. So I'm going to add 13. I get x squared plus 6x plus 9 to the 3/4 equals 27. Alright, I'm going to raise to the reciprocal now, so to the 4/3, to the 4/3. That kills it, which gives me x squared plus 6x plus 9 equals, this is going to be the cube root of 27 to the 4th. 3 goes into 4 one whole time. Take away 3 leaves 1. So 127 is out and 127 is in. So this is going to be 27 cube roots of 27. But the cube root of 27 is 3, and 27 times 3 is 81. So now I can solve this. I have a quadratic, so I've got to get 0 on one side. So minus 81, I get x squared plus 6x minus 72 equals 0. Factors of 72 that make 6 are 12 and 6. Since C is negative, only the bully gets the positive, so 12 is positive and 6 is negative. So solve it. X plus 12 equals 0, minus 12, x equals negative 12. Add 6, x equals 6. And again, you need to check them, alright, on a calculator, but they both work. Alright, and you can see it crosses at negative 12 and at positive 6. Alright, so how do you solve radical equations? You isolate and raise to the index on both sides. Raise both sides to the index. How do you identify extraneous solutions? When you plug them in and you get a false statement. How are extraneous solutions related to the domain? Extraneous solutions have to be excluded from the domain. Okay, and this one, they want to know if it's true or false. What they're saying is the first step is to square both sides, which is true, but if they do square both sides, is that what they end up with? You figure it out and tell me if it's right or wrong. Alright, and we are at homework, so we are done. Happy homeworking, and I will see you next time.